So let's start with what actually the vector is. So simply put it, it's sort of a journey that you can describe of, and it's journey from one point to another point. And when we say that it's a journey between 2 points, we specify those 2 points. So in this case, for example, on your screen, as you can see, I have indicated two vectors. One is a vector AB and the other one is vector CD. Now, both these vectors are usually, first of all, they are specifying the point that it is starting from point A and going to point B, and the other one is going from point C to point D. How you define or describe the vector, it is usually drawn as a straight arrow, as you can see, and the 2 points, the starting point and end point, are joined together, and the head of the arrow is indicating the direction of the travel. So as you may see that for vectors, going from one point to another point, the important thing is that it is showing you the direction in which way you are proceeding on. For example, in A to B, the direction, the head is towards P, so you are walking towards P. In the other case, C to D, the direction is towards C, or the head is towards, head is towards D, so you are going from C to D. Another thing that is important when looking at the vector is that how you represent vector. So one way of representing vector, as you see on the screen, is writing the endpoints and drawing an arrow over it. Sometimes you may find in mathematics book that vector is written like this. Other times you may see some other textbook which may be seeing in which they are writing the vector, let's say AB. They will say this AB, point AB is indicated by distance R, or a point P, and they put a bar on the top of that alphabet or symbol, and this is representing a vector. Now, vector can be written as in terms of a column vector. When I say column, so as you can see over here, this 3, 4 is, sorry, I have lost it. Okay, yeah. So this column vector is represented like this, which is simply indicating that if you are looking at a graphical view, so obviously when you want to like I said, for vector, it is important that you know from where to where you are walking, in which direction. So if you look at it, you need to have a defined set of grid. So in this case, at the end, on the right hand side, you can see the figure over here that point A is lying somewhere here. Let's say it is 0. So what you are doing is that you are saying that the journey between A to B is pointing from point A to B, and how you are looking at this journey is that first you will count the 3 units in x direction. I'm talking about the column vector. So this 3 is representing the horizontal axis 3 units, and then the bottom one in the column vector 4 is representing the unit travel in the y direction. So this vector or this form is called the column vector, and if you look at it, you may find that in some mathematics book all the vectors are written in this form. So what I have done is that I'll try to use both these ways in solving out problems related to vector. So like I said, that it is for vector it is important that you know the direction, in which direction you are having the vector. So over here you can see again that there are 2 vectors. So here the one that I have presented earlier, vector AB. So now you can see A is the starting point and B is the end point. So you can write vector AB with the arrow over the top. However, the other way of writing vector can be that you name this distance by A, or B or P or R, but you place a bar over it. That bar is representing that it's a vector. The third way of describing the vector or writing the vector is that you make the alphabet or symbol bold. So for example, you can also write the vector A or P or any symbol, but you make that as a bold. So you may, if you look at various texts in textbook of mathematics, you may find any of these way of expressing a vector. Now a little bit about representation of a vector. So why we need to look at vectors? We need to look at vectors because you will find the use of vectors in most of engineering areas. For example, if you are trying to solve the forces acting on a body, for example, that's what you are seeing on the screen, that you have got a physical problem of pulling an object. So this is an object. This is an object with weight F, weight W, sorry, and its weight is acting downward direction, mg, and you're trying to pull it in this direction. So the angle between the horizontal axis and the force is 45 degrees. Now, in order to resolve the forces that are acting on this body and the forces that's going to make this body move in either direction needs to be solved out. And for that matter, if you look at it, the figure next to it is showing you the actual diagram with the forces resolved. So, for example, you will see that the force is being done in this direction, but force is being done in this direction, and it's going to push or pull the object in one way or the other direction. Similarly, the other force that is acting on this body is the weight of the body that will act in the downward direction. Opposite to this weight is the reactive force, which will act in the against the direction of the weight or in the opposite direction. So this is just one of the simplest example in which you can see that in order to solve the forces that is acting on this object, you can use the help of vector to resolve out the forces that are acting on this body of mass m. Let's talk a little bit about the magnitude of a vector, also called as modulus of a vector. Now, this modulus of the vector or a magnitude of vector is a special property of vector, and it helps us to determine out the forces or the magnitude of the forces that are acting on a body. For example, the one that I have just shown in the previous slide. So a little bit about this magnitude or a modulus, that normally when you write the modulus, and I think just to remind you here that you have also used the term modulus or magnitude to find out the modulus or a magnitude of a complex number. It is similar to what you will do here in the vector. So the magnitude of a vector, it can be written as a bold, or it can be written in the sign modulus, absolute value, because this needs to be always positive. The magnitude is always positive, so hence you will put it in terms of absolute value. And this magnitude will result in the length of the vector, and hence it is a scalar value. In the bottom of the slide, you can again see how it can be represented. You can represent it with an arrow, or you can represent it as a bar. You can represent it as the endpoints, or you can represent as a scalar value or the length of the vector. This is what I mean, that starting point is A, ending point is B. The length between A, B is A. A is in vector, and you can find the magnitude or modulus of vector A with the help of the same formula that you know earlier, that is under root A square plus B square, if it is a 2D vector. And if it is a 3D vector, then it is under root a square plus b square plus c square, just like what you did in your previous topic. A little bit about unit vectors. So unit vectors in mathematics, usually the number 1 is referred as unit. So in terms of when you are dealing with vectors, you divide any vector by its own magnitude. It will produce a vector which is same as the original vector but with a unit magnitude. And that's because the magnitude of this vector, resulting vector, is 1. It is called a unit vector. Also given special name as magnitude equal to 1. Or it is sometimes in different mathematics book, they try to differentiate this vector, unit vector, from other vectors by writing it as a hat over the symbol or the alphabet. For example, in this case, I just explained that this is A over A with a bar over it is a vector. However, the A with a hat over it is a unit vector of A. So it is the unit vector of A which has same direction but its magnitude is just 1. Now why we need this unit vector, I will explain in more detail in the later slides when we will deal with 3D vectors. Now, another thing that you should be familiar of is equal vectors. Now, what do I mean by equal vectors? Equal vectors, where two or more vectors are equal if they've got same magnitude and same direction. For example, you can see on your screen that again I have given you an example of vector AB with the magnitude. This AB vector has got same magnitude and same direction with another vector CD. In this case, they doesn't have to be necessarily on the same point of the grid, but their magnitude and directions are same. So again, when we come to the next slide, when we are doing the problems related to the vectors, then it will become more clear what are these definitions of unit vector, equal vector, negative vector, what are these? It will become more clear to you when we'll try to do the properties of vector and do some examples. Then we talk about negative vector. It's just when you are having two vectors, they have got same magnitude but opposite direction. In equal vectors, magnitude was same, direction was same. In negative vectors, let's say A and B are two vectors, then A and B can have same magnitude but they can have opposite direction. When this is the case, then you say it is a negative vector. And in terms of how do you write a negative vector, you can write that if there are two vectors A and B, A is in positive direction, then the same vector B will have same magnitude but it will be in opposite direction. And this is how you can write the vectors, negative vectors. A little bit about addition and subtraction. So considering that on the screen you can see the number line, A is on a number line at 2 and B is on the number line at 5. Now each of these steps that from A to B a person is going to take, let's say is walking. So each step 2 to 3, 3 to 4, 4 to 5, it is a vector. And what we can do is that we can add these vectors up to give us the total length, and that is going to define us vector AB. Hence, in this case, you can see that if each of these steps is representing V, it can be said that the distance between A to B is 3v. Or simply put it, 5 minus 2 is 3. Now scaling the vector v to create a journey AB. This is what I have done. Now if you look at the negative vector, just now I have said, so if you go back from B to A, you will see the same distance, but now it is in the opposite direction. So it is a negative vector. Scalar and vector. Now, often when you are studying this topic of vector, you will come across these two quantities defined as scalar or vector. And how you differentiate, it's very important. For example, in case of scalar quantity, you have got a magnitude, but you don't have any specific direction. For example, time, speed, density, because time, it's moving, yeah? Speed, something representing something is moving with respect to distance, okay? Density is a physical quantity, but it's not representing any direction. So such quantities which do have the magnitude but does not specify that direction thing, they are scalar quantities. Compared to it, vector quantities are the one that not only have got magnitude, but it also have got a direction. And on the screen, you can see some of the examples of those vector quantities. For example, it could be velocity. Now you know the distance between speed and velocity. If you look in terms of unit, speed has got a unit of meters per second. Velocity has got a unit of meters per second. The only thing that differentiates between speed, which is a scalar quantity, to velocity, which is a vector quantity, is the direction. When you are defining velocity, you are stating in which direction it is moving or the object is moving. Similarly, momentum, acceleration, density, magnetic flux density, and weight. They are all representing the magnitude along with certain direction. For example, in the example that I started off, when the body is acting, a force is acting on a body, then there was a reactive force due to the weight acting in the downward direction, and because of this force acting in the downward direction, there was a reactive force that was acting opposite to it. So again, weight is a vector quantity because it is having a direction. Now, little bit about multiplication of a vector. So when you are having a vector and you want to multiply this vector by a certain scalar quantity or a scalar number, then how you do it? Let's say that scalar value is lambda. So if lambda is positive, then you multiply this lambda with vector A, you will get the vector of magnitude lambda multiplied by the absolute value of A in the same direction as A. In the same direction as A, which is already defined to you. Now, opposite to this, if you are having a scalar value, which is, let's say, a negative value, minus lambda, so in that case, again, the magnitude is same, that is lambda times absolute value of the vector, but that negative is showing you that it is in the opposite direction. So this lambda is representing that scalar value, or let's say in plain words, a number. So if lambda is greater than 0, then if you are having two vectors, they are said to be parallel vectors because both have got this scalar value which is making it which is greater than 0, and the resultant is that both the vectors are parallel. If the lambda is less than 0, and you can find out, and you are multiplying this lambda with A and B both, then they are said to be anti-parallel vectors, that they are opposite to each other. And then if you have got lambda equals to 0, that means that both these vectors are equal vectors. Adding and subtracting the vectors, it's very easy to add and subtract the vectors. The only thing that needs to be taken care of is to look at again the direction of vectors. On the screen, you can see three different examples. For example, in the first case, you see a vector A, and where the vector A ends, there is another vector B. What you can do under the circumstances is that you are asked that you need to add the two vectors. So what you can do is that you can add vector A value with vector B value, and you will get the sum of the two vectors. However, if the two vectors are in opposite direction, then what you will do is that although you are putting the two vectors together, you will look at the direction, the one that is in opposite direction will get the negative sign. So the sum of two or more the vector is called a resultant. And we again, when we'll put the numbers into it, you will understand more clearly that what is the resultant when we are doing the properties of vector. Now, how can we find out the resultant of the vectors? So the resultant of this vector A plus B, which can be taken as C, how to find that C? Or A minus B is again another vector C. How to find that C? So there are basically two methods. One is the parallelogram method and other is the triangle method, which is head to tail method. So here, first we'll do the triangle method, also known as head to tail method. So in this case, you can see again, I have taken an example, the one that I have shown on the earlier, that there is a vector A, starting point is A, ending at point B, and there is another vector B, which is starting from point B and going on to point C. Both these vectors are indicated by A bar and B bar, and if you are interested to find out the resultant, you add both these vectors up. And how do you add? The simple trick at the start is that you place first vector, you place the second vector at the head of the first vector. And that's why it's called head to tail, because the second vector has got its tail attached to the first vector. And you can find out the sum of these two vectors by taking the sum of both these vectors. C is equals to A plus B. If in case the two vectors have, one of them have got an opposite direction than the first one, let's say in this case it's minus B, then what you can do is again you can follow the same, that you will take the positive vector first, and then you will place the other vector, the second vector, the negative sign, on the head of the first vector. Once you have done that, you will draw a line right from the starting point to the ending point of the second vector, which in this case is point C. So you start off from point A and you draw the line to point C, joining to point C. This is the resultant vector, which is simply C, and it is indicated by A minus B. Now, parallelogram method, or it's also a bit similar to the one explained earlier. What you do is that you draw the vectors and you put the ends or tails of the vector together, or the initial points together. For example, in this case, there is a vector AB, the red one, and you can see the tail at the point A, and you have got another vector AC. So you are placing the tails of the two vectors together. Now what you do is then you draw the lines to complete a parallelogram. For example, you will shift this vector AB from here to the head of vector C, So you see it is almost parallel from the original vector, which is this dotted one. This dotted one is almost is parallel to this AB. Similarly, the vector AC will have the parallel form of vector over here, B to B ending on this. And once you have filled in this, the diagonal will form the resultant vector, which will start from the initial point A and it will end to the opposite vertex of the parallelogram. So if you look at it again, the journey is A plus B is resulting in C. And opposite to this is again the similar situation when you have got one of the vector has got a different direction than the first vector. So in this case, it is, for example, in this case, as you can see, it is C is equals to A minus B. And this minus sign is because of the opposite direction of the vector B. A little bit description about parallel vector and perpendicular vector. Although we're going to deal this again, but let me just clear that in case you are having a problem in which you have got two vectors defined. Let's say the first vector is written in this form. A is equals to AI plus A2J plus A3K. Now this is one of the way of expressing a vector where A, A2, A3 are the coefficients of the vector and I, J and K are representing the direction of the vector. I, J, K is just taken to be the unit vectors. In I is taken to be in the x direction, J is taken to be in the y direction, and K is taken to be in the z direction. So if you want to conceive the idea of IJK, take it XYZ plane. So if XYZ is a three-dimensional plane, then I is representing a unit vector of A, which is acting in the x direction. J is a unit vector of A, which is acting in the y direction, and K is a unit vector which is acting in the z direction. Similarly, the other vector B can also be resolved in the same way. So now this vector A and B, if you are solving them out and you are said that these two vectors are parallel to each other, then how you can find out is that whether these two vectors are parallel to each other is that if you look at their directional components are A1, A2, A3 and B1, B2, B3. So if you look at them, that the ratio of their directional components are same. For example, A1 over B1 is same as A2 over B2, which is same as A3 over B3. So it's sort of a condition or conditionality to see whether the two vectors are parallel or not. So when in case you find a question in which you are asked that these are the two vectors, find out if they are parallel vectors or not, then you can immediately follow this and you can find out if they are parallel or not. Similarly, if the two vectors, again I have taken the example of the same two vectors, you can find out whether these two vectors are perpendicular or not. And they are said to be perpendicular if the sum of the product of their directional component, again you can see that A1 and B1 are the directional component, so I times I. So this A1, B1 is plus A2, B2 and A3, B3 should equal to 0. So the sum of these directional sum of the product of these directional component should equal to 0. I will again come to the detail of the second one, that how we reach to this A1 B1 plus A2 B2 plus A3 B3 equals to 0. Okay. So let's talk a little bit about how you represent vectors. So initially I talked about I, J and K. So now I'll go in more detail that when you are representing a vector, 1D vector space x direction. So now you can see over here XYZ plane, and on this XYZ plane you can see that when you have got a one-dimensional vector space, it is X. When you are talking about two-dimensional space, then you are considering XYZ plane, and you have got a component. I'll come to the next, but again, you are having a vector in this plane between X and Y. Then you have got a Z or 3D plane in which you have got a plane YZ, XZ, and XY, all three planes together. So now the center point is, of course, just to remind, is origin. Coming to the unit vector definition, which I said was a vector with a magnitude 1. And if you take magnitude of 1, it is 1. So it's just a single step in any of the directions. So if the direction is X, then it is I. If that single step or direction is in towards Y, then it is J. And if that single step is in the Z direction, then it is K. So remember that I is associated with X, J is always associated with Y, and K is always associated with Z. You can't name them by yourself. So you always have to follow this, that I is representing unit vector on X, J is representing unit vector on Y, and K is representing unit vector in the Z direction. Now, for example, you can specify a vector by giving the coefficient or the directional component values. For example, in this case, you can see that I have specified the value of the directional vector, which is A1, 3, A2 is 4, and A3 is 2k. So if you can measure, or in fact you can place this point, you can identify this vector A in three-dimensional place over here in the figure on the right hand side, that you will take 3 steps in the Z direction, then you will take 4 steps in the Y direction, and then you will take 2 steps in the K direction. So I hope you understand that it's a three-dimensional vector specifying the value directional component 3 in the X direction, 4 in the Y direction, and then 2 in the K direction. Another way, just to make you clear over here, that in some books, if you want to refer to any textbook of mathematics, you may find that these unit vectors are not just indicated by I, J, K. You may find that they have got this cap over it. So I did explain you at the earlier when I was giving you the definition of unit vector, that sometimes you put a hat over the unit vector, which is again representing that it's a single step in either of the XYZ direction. So let's come to first example in which we'll try to put in the information of adding or subtracting a vector. And this time, as you can see, I have taken 2 vectors A and B, and these 2 vectors A and B have got their directional component defined. For example, in first case A, the first A1 is 1, A2 is 2, and A3 is 3. Whereas for B vector, A1 is -2, A next, the term with the J component, there is no J component. As you can see, it just consists of 2 components. So it has got an I component, a component, directional component in X direction, and a directional component in Z direction. It doesn't have a component in Y direction. It doesn't matter. You can do the mathematical operation in this case also. Those who already know those vector have got a background in vector, they can just do it by looking at it. But initially, it's better that we place a vector J in this vector B, and then resolve out what we need to find out. For example, we need to find out A plus B, B plus A, and A minus B. So let's take the two vectors. As you can see over here, I have written the vector A just as it is, I plus 2j plus 3k. However, if you look at vector B, here you can see the vector B consisted of two directional component A1 and B1 and B3. And I over here, if you look at it, I have placed the component that was representing the directional component in y direction. And if you look at it, I have placed the value 0 with it. So anything you 0, you multiply, you divide, you plus, you subtract, it will not play any role in it. However, when you are solving it out, if you place it, there is less chance that you will end up in error. So those, especially those that are doing this vector topic first time or maybe doing it after long time, I would suggest that doing this way will reduce the chances of doing any errors. Now following on this, we can simply add the two vectors the way I have explained earlier, that all you need to do is to add the directional component, same directional components together. For example, x directional components of both the vectors will add up, the y directional components will add up together, and the z directional components will add up together. This is how you will do the addition process. So over here, what is followed is that the x directional component, which is 1i, and over here it's minus 2i, what you will do is that you will take the directional component 1, as you can see over here, plus, because we are adding the two vector, and I'll put the negative 2, which is of course the opposite direction of the vector that is defined. So you can see over here that I have placed it as minus 2, with the similarity that both these directional components are in the x direction. Similarly, I will take the directional component in y direction, which is 2 plus 0. So now here you can see I could have written 2j directly over here, but just to tell you, because then I get some emails and something where students ask me that how did you do this? So this is the reason I am writing out here. Those of you who knows, it's good, but those of you who are doing it for the first time or after many days, you can see that by having that 0j, all you need to do is to put that value there. It will not play any role, but it will help you resolve the vectors easily. The last component is 3 plus 6k. Again, you can solve it together. Now a plus b, so a vector, b vector, you are adding that vector, resultant is another vector c, and this is the magnitude of this resultant vector c, that the I component, as you can see, is minus I. So in the x direction, your answer over here is minus 1. From here you are getting 2j, and from there you are getting 9k. Similarly, you can follow the other two example, which is b plus a. So over here you can see that now again all you'll do is the same process, and you will see that you will end up with the same answer. So when you are doing this process of addition and you change the position of the vector, it does not result in creating any difference. Now this is a special case. I'll come to the next slide and I'll discuss more when we are talking about the properties of vector, distributive property and commutativity of the vector again. But we will specify that with respect to scalar product and dot product. Now a minus b, similar to a plus b, you will take the two vectors and of course you will subtract, taking into account the magnitude of individual directional component as you did in your addition case. So for example, over here, 1 minus, this minus 2 will not lose its minus sign, but it will retain its minus sign. So hence over here you can then take it out in the, solve it out in the next step. So when you do that, you will see this minus by minus 2 will become plus 2. And then 1 plus 2 will be 3. In this case, 2 minus 0 is 2j. And here 3 minus 6 will result in minus 3. So basically, the addition of vectors that I've just explained, you can see over here with the help of two vectors A and B, the process of A plus B, B plus A, and A minus B. Now let's talk a little bit about unit vector first, and then we'll talk about the multiplication of a vector by a scalar quantity. I am taking the same two vectors that I have taken in example 4. And what I'm asking is that for this case, you find out vector 2a minus 3b, 2a minus 3b, and then the unit vector a. Now what you do is that you take the vector a and you just multiply the scalar value 2. So in this case, this 2a, a is the vector itself, but this 2 is lambda. Okay, so this, all you need to do is to multiply this 2 or scalar value with the vector. And what you do is that you multiply it with each of the term. So here what you can do is that you can multiply this 2 by the first directional component, which is 1i. So over here you can see. Then you multiply this lambda or scalar value with the 2 with the j component. So here it's 2 times 2. And you multiply this scalar value or lambda with this, that is 3 times 2. It shouldn't be, it should not be plus, it should be 3 times 2 of k. And when you have done that, next step, you can just simplify with the help of the conditions given, that is 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 is 6. So this is how you are multiplying a vector by a scalar value lambda, which in this case is 2. Similarly, you could also do the same with another scalar value when the lambda is minus 3. All you need to do is to multiply this minus 3 with vector b. And as you can see, I have retained this 0j over here so that you know that the j component is multiplied by it will be 0, but again it will help you solve it out correctly. So in this case again, you can see that I have calculated out this vector minus 3b, which is result of when a scalar value minus 3 is multiplied to it. Similarly, I can also do the same, that I can use the results of 2a and minus 3b and use that, or I can solve again for 2a and subtract the other vector b by multiplying with 3 and then subtracting it again. So in either way, my answer will result in the same. I would come to the last part, which is finding the unit vector. So now when you are asked to determine a unit vector, if you go back and look in the slide, the unit vector was actually found out by the vector dividing by the magnitude or the modulus of that vector. So the vector when divided by its modulus or the magnitude of its vector. So in this case, what I have done is that I will find out this modulus or the magnitude of vector A, which I said was just the square of the directional component. So now in this case, the directional component of this vector A has got I, j, k. So it will be 1 square, 2 square, and 3 square. So over here you can see on the screen that I am trying to calculate out the modulus of this vector A, and which is 1 square plus 2 square plus 3 square, and the answer of this will be under root 14. It's a surd, so I will leave it as it is, and what I will do is that I will place this under root 14 as indicated in the formula. So the unit vector A of this vector A is represented by this value 1 over under root 14. So you can see over here, 1 is the component directional in the x direction of this vector A. 2 is the directional component in y direction, and 3 is the directional component in z direction, and under root 14 in each case is the magnitude or the modulus of the vector. So this is how you can find out. Maybe if it was not a cert, you could simplify it further, but at the moment I have just kept it as same. If you want, you can proceed it forward, and you can also specify it in terms of decimal if you want. So it's up to you. But this is the unit vector, and this value, this unit vector is can also be found out for the other one, which in case you can again find out the magnitude of this vector b, and then you divide this vector b with the magnitude along for all the directional components. You will get the unit vector of this vector b. So do that as a practice. I have done this for vector a. Try doing the same for vector b. The other thing is that once you have calculated out this unit vector, you can check it whether you have determined it correctly or not. That is by finding out the modulus of the unit vector. So if you find out the modulus of a unit vector, it just means that you put the coefficients or the directional components of the unit vector in the same way as you have determined the magnitude or modulus of the original vector A. So by placing them in the same formula, you can simplify and you'll find out that the modulus or the magnitude of unit vector is 1. And that's why it is called unit vector. If you remember the definition at the start when I was talking about the unit vector, that it was that the magnitude or the modulus of a unit vector is 1. So you can see by yourself that in this case you have determined out that the value that you have found out, that you can, when you find out the modulus, it is coming to be 1. You can do same for vector b as a practice. Any questions on this?
Shazia.
Yep.
So typically, are you given the scalars that you need to find? Like here it says find 2a, find 3b, or previously it says find a plus b. Are you given those in the question?
Yes.
So it could be different. It could be addition, multiplication. They could be.
Yes.
Various.
You are given that. I'm just starting from the very basic. Actual problems you will come to see a slide later, but this is how I'm trying to show you the individual processes like multiplication, subtraction, addition, and then we'll come to find out how to use these when solving out. Okay? A little bit more about this I, J, and K so that now you know what this I, J, K are. I, J, K are the unit vectors and they are representing the direction. So if it was just simple A, you would have said, but it's not showing any direction. But when you are having this A with I, J, and K, it is showing you the exact position in the three-dimensional plane. Now depending, we'll start off with the two-dimensional plane, that is a 2D vector, and we are considering this figure on the right-hand side where you can see you have got a resultant vector P. This resultant vector P could be simply resolved into component in x direction and component in y direction. So for simplicity, I'm saying that the component in x direction is a vector and the component in y direction is a b vector. When I'm saying that, and I am sure that you must have done this resolving a resultant vector or force vector maybe back in your GCSEs, that in this case I am saying that this vector A is lying on the x-axis, hence the component directional of this vector A is just I. And in this case, this vector B is lying on the y direction only, it's lying on the x-axis, so it's just got that y directional component, which is j. So it is defining the direction in that direction. Now, just like previous, you have to find out the magnitude of the vector. You already know that the magnitude of the vector or the modulus of a vector can be indicated by under root a square plus b square. And this is how you can determine out the magnitude of a resultant vector p. So if you are in, obviously you would want to know what is the distance between this 0 to this point. And this distance between 0 to this point, ending point, can be found out by this formula, magnitude of a vector. All you need to do is to take the value, directional component value a square plus directional component value of the other vector, which is b. You take the b square and you find out. Now, when you are representing this 2D vector, like I said at the start, how you represent a vector, you represent it as a column vector. So this is how you represent a 2D column vector, that you place the x directional component as a first element, and at the bottom of it you place the second directional component, which is b in this case. Okay, so this is sort of a revision that we have done in the previous, and now you can see and see together that how to define resultant vector. Let's say if I had not named it as P, this could have been named as C. Remember when I said that you are having two vectors, adding, subtracting, the resultant is another vector. So this P can be C. Okay, so I can find out the value of this resultant vector C with the help of these formulas, like for magnitude of a vector, and then how to represent the resultant vector is by making it in a column vector. Similar to this, we could also go that now you know how to do it for xy plane. If you've got a 3D vector, that means it has got a component, directional component in all the three directions, that is in x, y, and z. That means it has got a component I, j, and k. Now, if you want to write this 3D vector in column vector form, all you need to do is again place them in the same way, like A is the directional component in x direction, B is the directional component in y direction, and C is the directional component in the z direction. Now, as an example, 2D vector with 0.34. So again, I am giving you some information from the top that you have got this vector P, and it has got coordinates of 3 and 4. So how can you write this vector? You can write this factor in terms of column vector like this, 3, 4. Now you can see why I started off with that unit vector notation right at the start, and I showed you that how you move three steps in the x direction and 4 steps in the y direction. So now you can see that how you indicate a 2D vector, that is with the point coordinates 3, 4 set as coordinate of 3, 4, and how you indicate it in pure Cartesian form, that this is what the Cartesian form is, x, y, z, I, j, k. So you are representing this vector P as 3i plus 4j. So now if you look at it at the start, I said that this resultant vector P is ai plus bj. Now a is 3 and b is 4. I can find out the magnitude of this vector also, this resultant vector P, and that is by taking under root of 3 square plus 4 square. That is from the help of this formula, which you can see in terms of plotting this resultant vector P. This is how you'll plot the vector. So if you see over here, I and j are giving you the unit vector. They are unit vectors and they are defining the direction. Whereas this P, OP is representing the resultant vector, okay, which has got coordinate this 3 and 4. And how you want to define the distance or the length of this vector, 3i plus 4j. So this is representing the length of the vector OP. I hope this is clear. Problem with the help of any of these.